large triangular piece of plywood is to be painted to look like a mountain for the spring musical. The angles at the base of the plywood measure 76 degrees and 45 degrees. What is the measure of the top angle that represents the mountain peak?
So base of the plywood is measured of 76 and 45. So let's draw a triangle. Because I don't want to assume, why not just start with the scalene? So I have 76 degrees and 45 degrees. The peak is the unknown. What should I do to find the peak? Set it equal to 180. Could I just add these two and subtract it from 180? Pretty much the same thing. So how many is 76 plus 45? 121. So if I take 180 minus 121, that's going to give us how many?
59.
Boom. 59. For example number 3, can I assume that this triangle looks like something? Is there any information on here that says is a scalene, isosceles, equilateral, or any of that? But we do know all the angles together must be how many? 180. So I have 7n minus 8 plus 2n plus 4 plus 6n plus 4 is equal to 180. When I combine the n's, I get 15n. And I know the constants become a zero pair since we have a negative 8, positive 4, positive 4. So 15 can go into 180 about how many? It should be pretty clean. More than 10? 12? And then it says to find the measure of each angle. That means we need to plug it into each individual. So we have 7 times 12 minus 8, 2 times 12 minus, plus 4, 6 times 12 plus 4. So we know the measurement of angle T, measurement of angle R, and measure of Y. Okay, someone compute the T. How many degrees is my T? Okay, somebody else give me R. How many is my R? 76 also. What about the Y? 28. So now that we found the angle measures, what kind of triangle is this specifically? An isosceles. But again, don't ever assume unless I've stated that for you. Okay? All right, Abby, let's read example number 3. When you ever see the phrase ratio, that means we have a common variable. And that common variable could be added on to 3x plus 4x plus c5x. That was 3, 4, 5. How many is our total triangle sum? 180. You guys done? Okay. So then when I go ahead and put them together, we get 12x is equal to 180. So x must be how many? 15. And then if x is 15, the ratio of 3 means 3 times the 15, 4 times the 15, and 5 times the 15. So we have 45 degrees. What's the other one? 60 degrees. And how many is the third one? 75 degrees. Boom, done. So if you ever see the ratio, just put in the x's. It's a common value or common variable. All right. Number 4, Nick, let's read.
The measure of one acute angle of a right triangle is 23 degrees. What is the measure of the other acute angle?
Okay, I want you to make a little dividing line. First, I'm going to do it the traditional way that we've always been doing so far. So we have one acute triangle of a right triangle is 23. The unknown is my x. So let's take it traditionally. What can I set all of these 3 equal to? 180. So we have x plus 23 plus 90 is equal to 180. Could I also say, well, since I have a right triangle, could I make the number easier and say x plus 23 is equal to 90? Does everyone see that? Does that mean that's the best method? If you get a brain fart, always go back to the traditional way. Nothing wrong with it. So we know our x has to be 67 degrees. This will be helpful when you get to homework, problem number 2. And I'm going to write out the sum, not the sum, the theorem. The sum of two acute angles will always be equal to 90, only because it's a right triangle. I'm going to bubble that off to the side. Is everyone good with that? All right. For the next part, I want you to go ahead and name the triangle ABC. And I'm going to actually prove it to you after I go over it. And then I want you to go ahead and name the exterior angle D. So let's go to that exterior and emphasize. And I'm going to circle the 2 remote interior. It is interior because it's inside the triangle, and it's remote, as in it is away from the exterior. Because angle A is adjacent, angle B and C are remote of the angle D. So let's go ahead and name these 2. This one and this one is called remote interior angles. And then right out here is the exterior angle for the obvious reason. And let's write the theorem pertaining to this. Here's our exterior angles theorem. Measure of the exterior angle of a triangle is equal to the sum of the 2 remote interior. Write that off to the side. So when I add the 2 remote interior, it must be equivalent to the outside. And I'm going to prove it. Okay, when you're ready writing the theorem down, give me a thumbs up. Okay, if you care for the proof, cool. If you're like, hey, that wasn't all that great, that's okay. All right? Do you see a triangle? Okay? So then I'm going to move this up. If I go ahead and cut the angles of the triangle, and I line them up with the vertices pointing downward, although this is a little bit bent. Should it be straight? Because it is 180, right? So let's see if that is true. Do all the angles line up straight? Yes. Yes, it is. So here's the idea. I'm going to go back. Do you agree? A, B, C equals 180. Do you agree D and A equals 180? Does it then make sense that angle D has to be equivalent to B plus C? Yes. If that makes sense, cool. That was your magic of the day. All right. So with that said, let's do example 5 with a neighbor. Go. Say, hi, neighbor. Long time no see.
How close is it burn? When did you go back? We don't have school Friday. Why did you leave tomorrow?
RHS first. So we play our varsity on Thursday.
Oh, varsity is Thursday.
All right, do we need explanation on this one? Are we sure? Okay, let's go on to number 8. On number 8, it's not just giving you the angle measurement, it's giving it to you as an expression. So let's go ahead and highlight the angle on the outside and circle the 2 remote interior. So when I add these 2, I must get the exterior. So we have 23 plus 5x minus 1 is equal to the outside, 9x plus 2. And then when I go ahead and put them together, we get 5x plus 22 is equal to 9x plus, is that 2? Let's do two things at the same time. I want to minus 5x on both sides. At the same time, subtract 2. If you want to take it one step at a time, go for it. So I get 10, oh, not 10, 20 is equal to 4x. So how many is my x? 5. But then the question says, find the measure of each angle. How many angles do we see here? I see 3 of the inside, and then the 4th one is on the outside. So let's be specific and name it. I have measurement of angle P, measurement of angle Q. P was already given though, right? Silly me. And then we have the measurement of, and be really careful. Do you see this angle R is pertaining to 2 different angles here? So you have to use 3 letters. So P, R, Q, and then P, R, S. So let's plug in 5x minus 1 by plugging in the 5. How many is my angle Q? 24. Since I know 23 and 24, can I add them up and subtract it from 180? Yeah? And that should give us PRQ as some number. How many is our PRQ? 133. Very good. Forgot my degree signs. Now for PRS, I can choose to plug it back in, or I can use my supplement and say, why not take that from 180, right? Which I think is easier, 47. So if you want to plug it in, by all means, go for it. But if you know the logic of your linear pairs, that's also okay. Everyone good with that one? Okay? All right. Now I want you to write this phrase on the third angles theorem, on the line provided. It's going to sound pretty redundant. So the third angle theorem states, if 2 angles are congruent to 2 angles of another triangle, then the third angles must also be congruent too. And I'll show you with the visual. Because we like examples with the numbers. It makes a lot more sense. Okay, when you're ready, give me a thumbs up. Okay. Okay, let's look at this figure here. These 2 are congruent to, these 2 are congruent to. So let's see. Let's say I let A be 30. Then what do I know about angle D? Is also 30 according to our notation. Let's say I let B equal 80. What else is 80? E. Given those 2 angles are congruent to the 2 angles of the other triangle, do I know these 2 must be congruent no matter what? Yes. That's all that is stated. Okay? Without a specific example, it's hard to get to, but with the number, I think it makes a lot more sense. So 7 and 8 is pretty much the same thing. Let's just do number 7. All right. Could I use my third angles theorem on number 7? Yes. If these 2 are congruent and these 2 are congruent, what do I know about these 2 angles over here? They're also congruent. So we have 4x squared is equal to 3x squared plus 25. Let's subtract 3x squared on both sides. So I have just 1x squared is 25. Then what must be my x? 5, good. Solve for x, we did. Find the measure of each angle, meaning these 2 given angles on this one. So we know measurement of angle C is how many? Plug in the 5. 100. And then would that also cause angle F to be 100 as well? Now here's another question then. Is there any way for us to find angle B or angle A? There isn't a way, okay? Because we know between those 2 together has to be 80, but we don't know what's going to take. It's going to take more or less, okay? So this is the only information we could find.